Okay, guys, let's start Unit 7. Okay, so we did Unit 6, now we're doing 7. So first thing we're going to talk about is we're going to talk about something called the wave nature of light. So let's talk about the atom, which we're already familiar with. Now we know that the atom it's made out of 3 subatomic particles, right? Protons, neutrons, and electrons. The protons and the neutrons are in the middle, the nucleus. So the nucleus of the atom is positively charged. And then the electrons, which are negatively charged, fly around the nucleus. Okay, that's pretty much the basis of atomic structure. We know that positive and negative are attracted to each other, so this attraction is what keeps the atom together. But we also know that the electrons, they push each other away, right? Because like charges repel. And so this balancing act is what kind of keeps the atom together. All right, now, electrons can leave the atom. Okay, they can get kicked out of the atom. We call this ionization. And so if an electron is removed from the atom, we call that ionization. And the amount of energy that is required to remove an atom is called ionization energy. Okay? So ionization energy is the energy needed to remove one electron from the atom. We're going to talk a lot more about this in a bit. Just make sure you have that definition somewhere. Okay, so ionization energy is the energy needed to remove an electron from the atom. All right, now there are 2 things that affect ionization energy. Again, ionization energy is energy needed to remove an electron from an atom. Think of it as the energy required to steal an electron. Okay, so think of it this way: the electron is your phone. Okay, ionization energy is how much energy it would take me to steal your phone from you. Okay, there are 2 things that matter when it comes to this. If you increase the distance, okay, so if your phone is far away from you, so if it's like over here, is it going to be easier or harder for you to take my phone from me?
Harder.
If it's over there, it's easier, right? So since it's easier, the ionization energy will go down. Okay, same thing with electrons. The further an electron is from the nucleus, the lower the ionization energy, the easier it is to take. Okay, so you increase distance, ionization energy goes down. Okay, the other thing you can think of is the atom's grip. We can call that the nuclear charge. It's basically how tightly it's holding onto the electron. So that's the symbol for that is Z. And if the Z, the nuclear charge goes up, if I'm holding onto my phone tighter, it's harder to take the phone, right? And so the stronger the atomic charge, the effective nuclear charge, the greater the ionization energy. Okay, so those are the 2 factors that affect ionization energy. The first is the distance. The further the electron is, the easier it is to take the electron. But the higher the nuclear charge, the higher the ionization energy. Okay, nuclear charge usually is going to be about the number of protons. There are some other factors that go into it, but think of it that way. Okay, just how positive is the nucleus. All right, everybody good with that? Those are the 2 factors that affect ionization energy. Now, there's a couple things that happen when you ionize or remove an electron from the atom. So let's say that we have our atom right here. So we got our nucleus right here, and then I'll do the electrons in blue. Okay, so there's these electrons flying around. Now, if an electron leaves the atom, so let's say we have this electron right here, and this electron left. So when an electron is removed or ionized from the atom, what happens is energy is released, and this energy comes in the form of light. Okay, so when you remove an electron, energy is going to be released, and it's released in the form of light. Okay. Now, when we think of light, we think about the color spectrum, we think about the light that we can see. But there are different types of light. You guys have probably seen the electromagnetic spectrum. We're going to talk about that in a second. But things like X-rays, radio waves, UV, things that we can't see, those are all different forms of light. We'll talk about that in a bit, but it's typically not going to be visible light. Okay. All right, now before we talk about this more in detail, we got to talk about light. So we're going to start by talking about some of the characteristics or the wave nature of light. So light has some different properties that we need to talk about, but light always moves in these things called waves, okay? Waves. And there are a couple characteristics of waves that we can do some fun math with. All right, so the first characteristic of light is called the wavelength, okay? And the variable for that is this right here. It's called lambda. And this is just the distance between two peaks. Okay, so the length of the wave. How long is the wave? That is the first characteristics. Okay, and just like any type of distance, we measure it in terms of meters, but waves are really, really small. So we don't use just regular meters. We use things like nanometers. We can use micrometers, things like that. And we'll talk more about this in detail, but just know wavelength is a form of distance, so we use some type of meters to describe it. Okay, so that's the first characteristic. First characteristic of light is wavelength. All right, the second characteristic of light is the speed of light, and we'll always pretty much have the speed of light at the same value. The speed of light is meters per second. The variable that we use to describe it is c, and I believe this is on your AP equation sheet. But light always moves through a vacuum at 3 times 10 to the 8 meters per second. Okay, you might also see a 2.98, but you can always round it up to 3. You'll get pretty much the same value. All right, and then the third characteristic of light that we're going to talk about is called frequency, and it's exactly what it sounds like. How frequently do the waves come? Okay, so the number of waves per second. So the variable that we use for that, it kind of looks like a V, but it has a little thing sticking out the side, and it stands for waves per second. Okay, but people get lazy, and so the unit of measurement oftentimes is just 1/second. And then we also measure it in terms of something called hertz. Okay, so if you have ever played with the radio, that's why we say something megahertz. It's because it comes from the frequency. Oh, sorry. Yeah, Z. I put a little slash through my Z's. HZ. So those are the 3 characteristics of waves that we'll need to know about. Wavelength, so the distance between the waves. The speed, which is always constant. It's always going to be 3 times 10 to the power of 8 meters per second. And then the frequency, which is basically how fast do the waves come.